Hello everyone, welcome to my YouTube channel Psychology Class for All. Today I will discuss frequency distribution. Before going ahead with frequency distribution, I will discuss about class interval. A class interval is a group or range of values in which data is divided for a frequency distribution. When data has too many individual values like IQ scores of 100 students, we group them into intervals. For example, 90 to 99, 100 to 109, etc. Each group is called a class interval. Class intervals makes large data manageable and readable. It helps in identifying patterns, trends, and shapes of distribution. It is useful in creating histograms and frequency tables. Now, about how to prepare class intervals. I will discuss it step by step. Let's assume we have IQ scores of 40 students ranging from 65 to 140. Now, the first step would be to find the range, and the formula for range is maximum value minus minimum value. Here, the maximum value is 140 and minimum value is 65, so the outcome is 75. The next step would be to decide the number of class intervals. Typically it used to be 5 to 15. We'll use the formula as number of intervals is equal to square root of n, where n is the total number of values. So for 40 scores, the square root of 40 is 6.3, so we'll use 6 intervals. The next step is to calculate class width. Class width, that means the size of the class interval. So the formula is range divided by number of intervals. So here range is 75 and number of intervals is is 6. So the outcome is 12.5. We'll use 13 or round up to 15. Next step is to decide the starting point. Start slightly below the minimum value, that is 60. Next step is to make intervals with its total frequency. So the picture is displayed over here, having class intervals starting from 60 to 74 and ending from 135 to 149. It gives us equal width class interval. Here, one thing needs to be kept in mind while preparing class interval, that always begin class intervals with the lowest observed value or slightly below it. If needed for neat class limits, then build upward using equal class widths because it gives logical sequencing and ease of interpretation. Now, about the types of class interval. There are several ways to classify class intervals. The two most important are: first is based on inclusivity, the name as inclusive and exclusive class interval. So, inclusive class interval has both lower and upper limits, and it is used for discrete data. For example, number of therapy sessions and all. For uh, For example, interval includes 10 to 19. Here, value 10 and 19 both are included. Exclusive class intervals, upper limit is excluded, lower limit is included. It is used for continuous data, for example, time and scores. The example of intervals could be 10 to 20. Here, 10 to 19.99 would be included, but the exact value 20 will go to the next class 20 to 30. Second is based on width or size. First is equal size interval. All intervals have the same width. It is common in statistical summaries. For example, 10 to 19, 20 to 29, 30 to 39, etc. The last is unequal class intervals that has got different width there, and it is used when data is sparse or skewed. Its example would be 0 to 10, 11 to 30, and 31 to 100. Now I'll discuss about frequency distribution and its types. Imagine you are a psychology teacher and you give a quiz to 10 students. These are their scores out of 10 I have written over here, like 6, 7, 6, 5, 7, 8, 6, 5, 6, 7. These are the random numbers. So you want to know how many students got each score. That's where a frequency distribution comes in. Frequency distribution helps in summarizing large data so it's easier to understand. It's the foundation for making graphs like histogram and for calculating averages later. So, a frequency distribution is a way to organize data so you can see how often each value occurs. Now, why is this useful in psychology? Psychologists collect data all the time, whether it is test scores, responses to surveys, or reaction times. After the data collection, to organize and analyze a data set effectively, we construct different types of frequency distributions. So we need to understand frequency distribution and its types. Now, we'll see the types of frequency distribution based on how the data is. So I have listed over here of 6 types. First, ungrouped frequency distributions. Second is group frequency distribution. Third is relative. Fourth is cumulative. Fifth is inclusive frequency distribution. And the last is exclusive frequency distribution. I'll discuss it one by one. So now we'll start with the first one, ungrouped frequency distribution. It's a table that lists each individual score and how often it occurs. So there is an example of scores on a depression scale. Now the frequency distribution table would be like this one. Here each unique score is listed. This is good when there are only a few possible scores. Here the score is a value. The frequency is how many times it appears. So score 2 and 3 appeared 3 times. That's the frequency of a score 2 and 3 respectively. Now about group frequency distribution. A group frequency distribution is a table that organizes data into class intervals rather than listing each individual value separately. It provides a structured summary of a data set by showing how frequently each interval occurs. Steps to construct a group frequency distribution is same as construction of a class interval at first. So, first of all, identify the range of the data, and the range formula is highest value minus lowest value. Now, determine the number of class intervals, calculate the class width. Here, one thing needs to be kept in mind is that width should be a whole number and should ensure that all values are included. Now, set class limits. Here, classes should be mutually exclusive, no overlapping values. And then tally the frequencies. Count the number of values that fall within each interval and record them. By taking a hypothetical data set, I have mentioned all the steps over here. Like it is a reflection of 30 students in this hypothetical data. Here we identified the highest and lowest values like 100 and 45. Then we need to determine the range, that is 55. Then we calculated the class width, that is 55 upon 6, and the result is 9.166, and so on. So rounding up, we use a class width of 10. Now we'll create a class intervals ensuring they cover all the data points, and that is reflected in the table. Like 40 to 49 has got one frequency, and 10 and 100 to 90 to 100 has got 10 frequency. When there are many different scores, that is easier to group them. We lose some details but gain clarity. Now about relative frequency distribution. A relative frequency distribution expresses the frequency of each class as a proportion or percentage of the total. Now we learn to construct a relative frequency distribution. The formula for relative frequency is frequency divided by total observation. Now, formula for relative percentage is relative frequency into 100. So, here in this table, it has been clearly depicted the of relative frequency of first frequency, that is 1, is 0.03, as it came after 1 has got divided by 30, and the relative percentage goes like 3.3 by multiplying the relative frequency into 100. So purpose and benefit of this frequency distribution is it helps compare different data sets with varying sample size, expresses frequency as a proportion, making it easier to interpret the trends. It is used in probability calculations and statistical analysis. Now about cumulative frequency distribution. A cumulative frequency distribution shows the total number of observations at or below a particular class interval. Here, each row shows the total number of observations up to and including that point. It helps in determining percentiles, medians, and quartiles. Types of cumulative frequencies are less than cumulative frequency. It shows the total number of observations at or below a given class. And the other one is greater than cumulative frequency, that shows the total number of observation above a given class. Purpose and benefit of cumulative frequency distribution is it helps in analyzing the percentile rank of all values used to determine median, quartile, and percentile. It is useful for graphical representations such as ogive, that is also known as cumulative frequency curve. Let us understand how it should be prepared by this example table. Here, three columns are there: IQ range, frequency, and the cumulative frequency. Here, first column is about the scores presented in a class interval. Next is the frequency of each scores falling under related class interval. Third column is about cumulative frequency. The second row is the addition of first and second frequency from the top, as 5 plus 12 is 17, written in the second row. Now 17 plus 18 is written as 35 in the third row, and so on, till the last row has 50 as the total of frequency. So if you want to know how many people scored below 120, cumulative frequency gives the answer. Now, there are additional technical classifications of frequency distribution that are important, especially for psychological research and statistics. First is Inclusive frequency distribution. In an inclusive distribution, both the lower and upper limits of a class interval are included in the class. Here is an example of that, 10 to 19. So 10 and 19 both are included. It is used when data is in whole numbers like test scores. The next is exclusive frequency distribution. In an exclusive distribution, the upper limit is excluded and the class interval includes values from the lower limit up to but not including the upper limit. In this example, the class interval 10 to 20 has got the values from 10 to 19, and the 20 will be counted in the next class interval, next row, as 20 to 29. It is used when data includes decimals such as reaction times, response durations, etc. If you are dealing with continuous data, for example, time taken in seconds, use exclusive classes. And for discrete data, that is number of siblings, we should use inclusive classes. So, to summarize, frequency distribution is a way to organize numbers. It helps to see patterns, a basis for charts and graphs. It is essential for psychological data analysis. And group data distribution simplifies data by using intervals. Relative frequency distribution shows proportion or percentages. Cumulative frequency distribution helps in understanding data trends and percentile. These methods are essential for organizing and interpreting large data sets in psychology, economics, business analytics, and scientific research. In the next video, we'll be learning percentile and percentile ranks. Keep watching. Thank you.